Okay, so looking at solving trig equations, just some general review stuff that will come into play in this with these. Cast rule, cosine is positive down here in the fourth quadrant. All ratios are positive in the first quadrant. Second quadrant, sine is positive. Third quadrant, tan is positive. Our special angles we've seen a few times. If you can't recreate these triangles yet, you need to be able to do that. Or I suppose if you've memorized the various ratios for pi over 6, pi over 4, pi over 3, that works as well. May come into play today. It hasn't too much previously. 0, pi over 2, and so on. The trig ratios for these as well can come up and are important. So if you see one of those, you should be able to recognize it. Either you know what it is or punch it into a calculator very quickly and you can figure out they're kind of fairly key situations where we have 0, 90 degrees, 180 degrees, and so on. And then the butterfly rule, of course, tells us that with our primary trig ratio in this quadrant, there is an equivalent trig ratio other than the fact that the signs may be negative or positive depending on which of the quadrants we're in, but there is that same ratio in each of the other quadrants. Now, second thing that's going to be important in this section, solving regular equations. Something like this, 4x squared minus 36. Because there is a single variable right here, we have a couple of options. We can rearrange the equation or we can factor it. And so two different options. If there is a single variable, isolate the variable. So in this case, we add the 36, divide through by the 4, take the square root of both sides. Square root of 9 is plus or minus 3. Second option, again, factor. So common factor is 4, x squared minus 9, x plus 3, x minus 3, so x is positive 3 or negative 3. And just a quick note there as well, probably should have had these in the opposite order because of course x equals negative 3 is the solution to this one, x is positive 3 is the solution to this one. Just me being lazy. In the second example here, I can't isolate the single variable because of course there are two occurrences of the variable, an x squared and an x, and so I must factor. I'm looking for two numbers here that will multiply to negative 10 and which will add to negative 3, and of course negative 5 and positive 2 are those two numbers, which means that x is positive 5 or x is negative 2. So how that's going to translate to the trig questions, we're going to look to solve much the same way we did with those first two examples, but we're looking to solve on an interval. So we're looking for all the solutions in the range of 0 to 2 pi. So basically we're incorporating this, sort of our butterfly rule with our solutions down below. And in this case, simple question to start, 10x plus 1/2 is 0. And so we're looking to simplify that. Again, as long as there's only the single unknown value, in this case 10x is the unknown value, I can simply isolate it, subtract the 1/2 from both sides, and then to solve this, inverse tan of negative 1/2, and that gives me an angle of approximately negative 0.4636 radians. Now where does that actually show up? Well, if we think about the fact that this is 0 over here and eventually 2 pi as we go all the way around our circle, this is pi over 2, pi, and 3 pi over 2. Negative any angle will be sort of rotating clockwise instead. So the first step is this is the negative 0.4636, but the range of answers we're looking for are those that are in the 0 to 2 pi interval. And so tan is what we're looking for, and tan of a negative value, which means our solutions will be cast. So cos is positive here, tan is positive here, all are positive here. So I'm looking for solutions in the second quadrant and in the fourth quadrant. We know this is a solution, although again, not the one we're looking for. We're looking for the first angle that leads us to the second quadrant here, and we're looking for the second angle, the one that leads us all the way around the circle to the fourth quadrant. And if we sort of work those out, in this case, I didn't quite reach pi, so I'm pi minus that 0.4636 around the circle, which is approximately 2.68. And then the second angle comes all the way down to here, doesn't quite reach the 2 pi, so 2 pi minus that will give us our second angle in radians. So cos squared, you can see again, a single occurrence of the unknown. And so rearranging this is fairly straightforward. Add the 3/4 to the other side, or to both sides, excuse me. Obviously it disappears from the left. We need to then take the square root. Cos squared x, for those who don't remember, is actually just a way that we write cos x squared. So it's our unknown value squared, just like back in the very first example. Just like this was x squared equals 9 and unknown value squared equals 9. This is an unknown value squared equals 3/4. Take the square root of both sides and we get, as we simplify here, x is plus or minus 3/4, plus or minus square root of 3/4. So plus or minus square root of 3 on top, and the denominator is root 4, or obviously positive 2. So once we know what we're looking for here is a ratio, we want to recognize that root 3 over 2 is the ratio for cos of pi over 6. And the fact that we have a positive and negative here means that this base ratio will appear, well, we know that this base ratio will appear in all four quadrants. The fact that we need the positives and the negatives means that we're actually looking for a solution in each of the four quadrants. So we're looking for this angle, so this angle as well, and so on. All four of our various options. These two stem from the fact that we have positive root 3 over 2, and then these two stem from the fact that we also need the negative root 3's over 2. And so if we go ahead and work those out, pi over 6 again is our primary trig ratio in the first quadrant, and then the second quadrant is essentially pi minus the pi over 6. Our third quadrant is the pi plus the pi over 6. And our fourth quadrant is 2 pi backwards, backing up, so minus pi over 6. And those become our solutions to that question.